Welcome back to my channel. Today we'll be continuing our series on electrocardiogram machines. The working principle of an ECG, electrocardiogram, machine is based on the electrical activity of the heart. The machine detects, amplifies, and records the electrical signals produced by the heart during each heartbeat. Here's a detailed explanation of the working principle. Number 1. Electrode placement. Electrodes are placed on specific locations of the patient's body, typically the chest, limbs, or torso. These electrodes are conductive sensors that pick up the electrical signals generated by the heart. Number 2. Signal detection. The electrodes detect the electrical impulses, known as action potentials, that are produced as the heart's muscles contract and relax. These impulses represent the depolarization and repolarization of the heart's chambers. Number 3. Signal amplification. The electrical signals picked up by the electrodes are very weak in amplitude. To make them more easily measurable, the signals are amplified using electronic circuitry within the ECG machine. Amplification ensures that even subtle electrical changes can be accurately detected. Number 4. Signal conditioning and filtering. The electrical signals may contain noise or interference caused by muscle movement, patient movement, or external factors. The ECG machine applies filters to remove unwanted noise and artifacts while preserving the essential cardiac signals. Filters eliminate high-frequency noise and baseline wander, resulting in a cleaner ECG signal. Number 5. Signal conversion. The analog electrical signals are converted into a digital format using an analog-to-digital converter, ADC. The ADC samples the analog signal at regular intervals and assigns numerical values to each sample, creating a digital representation of the electrical activity. Number 6. Data processing and analysis. The digitized ECG data is processed and analyzed by the ECG machine's software or algorithms. The software examines the timing, amplitude, and duration of the electrical events within the heart's electrical cycle. It identifies and labels various components of the ECG waveform, such as P waves, QRS complexes, and T waves. Number 7. Data display. The processed ECG data is displayed as a graphical waveform on the ECG machine's screen or printed on paper. The waveform represents the electrical activity of the heart over time. Each deflection in the waveform corresponds to a specific electrical event occurring during the cardiac cycle. Number 8. Interpretation. Medical professionals interpret the ECG waveform to assess the heart's electrical activity and diagnose any abnormalities or conditions. They analyze the shape, duration, and intervals between different components of the waveform to identify irregularities, such as arrhythmias, conduction disorders, or ischemic changes. Number 9. Storage and reporting. The ECG machine often has the capability to store recorded ECG data for future reference and comparison. It may also generate a report that includes the waveform, analysis results, and other relevant information for documentation and communication with healthcare providers. While ECG machines are highly accurate and reliable, there are some potential sources of error that can affect the readings or interpretation of the results. Here are some common errors that can occur when using an ECG machine. Number 1. Electrode misplacement. Incorrect placement of electrodes can lead to inaccurate readings. If the electrodes are not positioned properly or are not securely attached to the skin, it can result in signal distortion or weak signal quality. Number 2. Artifact interference. Various types of artifacts can interfere with the ECG signal, leading to false readings. Examples include muscle movement, patient shivering, loose electrode connections, electrical interference from nearby equipment, or external electromagnetic signals. Number 3. Poor electrode contact. Inadequate skin preparation or poor electrode adhesion can result in a weak electrical connection between the skin and electrodes. This can cause signal attenuation or inconsistent signal quality, leading to inaccurate ECG recordings. Number 4. Motion artifacts. Patient movement during the ECG recording can introduce motion artifacts, which can distort the waveform and make interpretation challenging. Movements such as talking, coughing, or breathing heavily can produce unwanted noise or baseline shifts. Number 5. Electrical interference. Electrical interference from nearby equipment or electrical sources can introduce noise into the ECG signal. This interference can result in distorted waveforms or false readings. Proper grounding and shielding techniques can help minimize this type of interference. Number 6. Improper gain or filter settings. Incorrect settings on the ECG machine, such as gain or filter settings, can impact the amplitude or frequency characteristics of the recorded signal. Inaccurate settings can result in waveform distortion or loss of important signal details. Number 7. Technical malfunctions. ECG machines are electronic devices and can experience technical malfunctions or calibration issues. Faulty hardware, software glitches, or calibration errors can lead to inaccurate readings or abnormal waveform presentation. Number 8. Misinterpretation. The interpretation of ECG results requires expertise and experience. Errors in analysis or misinterpretation of the waveform by healthcare professionals can lead to incorrect diagnoses or missed abnormalities. There are several well-known brands that manufacture ECG machines used worldwide. Here are some prominent brands in the ECG machine industry. Number 1. GE Healthcare. GE Healthcare is a leading global provider of medical imaging, monitoring, and diagnostic equipment, including ECG machines. They offer a range of ECG solutions for various healthcare settings. Number 2. Philips Healthcare. Philips is a renowned healthcare technology company that produces a wide range of medical devices, including ECG machines. Their ECG machines are known for their advanced features and reliable performance. Number 3. Schiller AG. Schiller is a Swiss-based company specializing in the development and production of medical devices, including ECG machines. They offer a comprehensive range of ECG equipment for both clinical and ambulatory use. Number 4. Nihon Kohden. Nihon Kohden is a Japanese company that manufactures a diverse range of medical equipment, including ECG machines. Their ECG machines are known for their high quality and innovative features. Number 5. Mindray. Mindray is a global medical device company based in China. They offer a wide range of medical equipment, including ECG machines, that are known for their affordability and reliability. Number 6. Welch Allyn. Now part of Hillrom. Welch Allyn, now part of Hillrom, is a well-known manufacturer of medical devices. They produce ECG machines designed for both primary care and hospital settings, known for their user-friendly interfaces and portability. Number 8. Mortara Instrument, now part of Hillrom. Mortara Instrument, now part of Hillrom, is a respected manufacturer of diagnostic cardiology equipment, including ECG machines. Their products are recognized for their accuracy and advanced ECG analysis capabilities. Hello everyone! I'm excited to announce that we have a fantastic video coming up next week. We'll be continuing our series on medical devices. So mark your calendars and stay tuned for our upcoming video release next week. You won't want to miss it.